Alright, so today I'm doing these two problems. G of x equals xe to the negative 3x, and h of x equals x plus 1 over x. And what we're going to be doing with these problems is to find the critical points and determine if they are a local min or local maximum. And to start out, we're going to be doing the g of x equals xe to the negative 3x. And what you're going to do first here to find the critical point is to find the derivative. And hopefully you know how to find the derivative by now. I'm not going to, explain how to find the derivative. Hopefully you know how to find it. And so all you do is you bring the negative 3 out. You got x plus e to the negative 3x. And these two things right here are just graphs. I'll explain those later on. But the derivative, so the first derivative of f prime of x equals negative 3e to the negative 3x, x plus e to the negative 3x. And now what you're going to do with this is set it equal to 0. And what I'm going to do is I'm going to try and make the problem a little easier. So I'm going to do negative 3xe to the negative 3x plus e, plus e here, plus e to the negative 3x equals 0. And it's still the same thing, I just moved around some x's there. So after that, what you're going to do is it's still set equal to 0, so now we're going to try and solve. E to the negative 3x, and then 3x minus 1 equals 0. And all I did was I took out an e to the negative 3x there to make it easier. This just is cluttered, and this is a lot easier to see. So now we're just going to go negative 3x. We're going to set each one equal to 0 here, and then 3x minus 1 equals 1/3. And now, since it equals 0, there's no critical point there. So our critical point for this problem is 1/3. And now we're going to determine if it's a local min or a local max. And what you need to do for that is to find the second derivative. So I'm just going to go over here because I'm kind of running out of space over there. So our second derivative for this problem, all you do is you just distribute the first derivative again. So it would be 9e to the negative 3x. And then you go x negative 6 to negative 3x. Now, once you get your second derivative, it's quite easy to find the local min or max. All you do is you plug in the critical point we found to the x. So we'll go 9e to the negative 3 to the 1/3 to the 1/3 minus 6 to the negative 3 to the 1/3. Now, once you do that, you find that it's going to equal, once you math it out, distribute, you can plug it into your calculator, either one. You get negative 3 over e. And now once you get negative 3 over e, you know this is a local max because it is negative. So if you plug it into, this is called the second derivative test. And if it's positive, then it's a local minimum, and if it's a negative, then it's your local maximum. So the 1/3 is going to be a local maximum. I'm just going to say max because I don't want to write it all out. And so that's our problem for the first. Our critical point is 1/3, and that is our local max. And another way you can do this, it's a lot easier. You can just plug it into you can just put this into Desmos or your graphing calculator, either one. And you can see right here that we're going to have a local max. And you just go second math or whatever it is, and you just go min or max, and you can see, and then you just second, enter. And you'll get it that way. It saves you a lot of time. It's a lot easier to do if you do it that way. Or on Desmos, you can just look at the graph practically. So that's for the first problem. Whoops, dropped that. I got the second one right here though. The second one, it's a little easier, I think at least. And that's h of x equals x plus 1. Alright, So for the second problem, I did it and it wasn't recording, so I'll just do it again, no big deal. I think this one's a little easier actually. So we got h of x equals x plus 1 over x. And this is what the graph looks like if you plug it into Desmos or your graphing calculator. And what you want to do first is to, find the first derivative, f prime of x equals 1, negative 1, whoops, not negative 1, 1 minus 1 over x squared. And that's the first derivative, so that's what we need first. And what you need to do is to set it equal to 0. Just like the first problem we did, I'm going to make it a little easier, so 1 over x squared equals a negative 1. And then after that, you get x squared equals 1. Once you get rid of those, the negatives, and you subtract, then you square root both sides here. Once you get that, you get x equals 1 and x equals negative 1. And then to find the critical point, all you do is you plug these, the 1 and negative 1, back into your first derivative. I'm not going to do that, I'm just going to cut time. You know the derivative, you just plug it into x. And f of 1 equals 2, and f of negative 1 equals negative 2. So your critical points are 1, 1, 2, and negative 1, negative 2. Those are your critical points. And now we're going to determine what the local min and what the local maxes are. And to do that, you're going to find the second derivative. So f, here we go. So once we do this, you just find the derivative again, and you get 2 over x to the third. Now all you need to do is to plug your 1's and your negative 1's into x. So you got 2, just like we did for the first derivative, you got 2 over 1 to the third, and you also have 2 to the negative 1 to the third. And you get 2, and you get negative 2. And just like the other thing, your negative, this one right here, if it's negative, it's always going to be your local max. If it's a negative, it's going to be local max. If it's positive, right here, then that's going to be your local min. So for the problem, you have negative 2 is your local max, and 2 is your local min. Oh, I'm sorry. Not 2. It wouldn't be 2. It would be your negative 1. So your negative 1 here, since it's negative, it would be your local max. Max here. And then since this is positive, it gives you a positive answer. 1 is your local minimum. Yep, so these are your local min and local max, and then this right here is your critical point. And like I said, you could just find your local min, local max. You can plug it into your calculator, you can do that, you do second math, you can go to Desmos, you practically just use your eyes and see or for these two problems, you could just see the local mins and local maxes. If you are familiar with these problems, you'll get used to them. So yeah, that is how you find the critical points to determine local min and max for g of x equals x e to the negative 3x, and h of x equals x plus 1 over x.